In this video walkthrough lesson, we're going to continue our fractions module, and this is lesson 5-1.5, adding fractions with like denominators on a number line. And these are the standards featured in this video walkthrough. We'll be using this worksheet. You can go to worksheetsandwalkthroughs.com to print out a copy for yourself, and you'll find it under our fractions video walkthroughs. Under the fractions module section, it's entitled Fractions Module, lesson number 5-1.5, adding fractions with like denominators on a number line. There are actually two pages that you'll be able to print out, page 1 and page 2. There are directions for each page, and here are the first directions. For numbers 1 through 4, show each expression on a number line, then evaluate the expression. So let's get started. This is number 1, and we have the expression 1/4 plus 1/4, and we need to show this on a number line. So we'll go ahead and do that. So automatically I'm going to mark off the 0 point where 0/4 will be, and we'll move left to right and label 1/2. And 1/2, we've seen that if we're dealing with fourths, it would take 4/4 to equal 1/2. So we have 4/4 at that end. Now I like to divide this in the center here. And really the center between 0/4 and 4/4 would be, you're probably thinking this, 2/4. Good for you. So there you go. We've got 2/4 right in the center there, and I'm going to label off these other sections as well. Now, let's take a look at how we can add this. All right, we want to start with, at the 0 point, and we're going to add 1/4 to that. So here we go. We have 1/4 here, and then we're going to add another fourth to that. Let me just back up a little bit. We're going to add another fourth to that. Like I said, 1/4 plus 1/4, and you can see this on a number line. Number lines are great for showing linear distance. So there we have that, and let's go ahead and label what we've done. 0/4 plus 1/4 equals 2/4. You can see that. We've traveled this distance here from 0/4 all the way to 2/4. 1/4 plus 1/4, there you have it. 1/4 plus 1/4 equals 2/4. Well, let's move on. In this case, we have 2/6 plus 3/6. So I'm going to again label the 0 point as 0/6. Close up that 0, make sure it doesn't look like another 6. So then we have 1/2 on this end, and again, we can express 1/2 as a fraction with a denominator of 6. Right here we have 6, and that would also be 1/2. So anytime you have the same number in the numerator and denominator, your fraction will be equivalent to 1/2. So let's get moving here. We have to add 2/6 plus 3/6. Let's see. So I'm going to mark this off in 6, and I'll see the halfway point would be right about there, and that would be 3/6. And let's see, I would have it divided off here. So there's 3 sections here, and then 3 sections here for a total of 6 equal parts in 6. That's what we have. So now we want to add these up. We'll go ahead and do that. We'll start off at the 0 point, and the first fraction down here tells us we have to add 2/6. All right, we'll start off with 2/6. There we are. And then we're going to add 3 more 6 to it. 1, 2, 3, 6 to that. Let's see where we would end up. So once again, we started off with 2/6, so there's 1/6 plus 1/6 would equal 2/6. And then we want to add 3 more to that. So we went 1, 2, 3 more would be, if we kept counting, we go 3/6, 4/6, and then 5/6 would be right over here. 5 6. So therefore, we can evaluate this expression, and we'll add these two together. We've got 2 6 plus 3 6 equals 5 6. Very good. You're probably noticing a trend here, a pattern. If we have the same denominator and we're adding fractions, you can simply add these numerators up. We're kind of proving that here on the number line. It's always good to prove you know what you're doing in math. So there's the answer to that one. The sum of 2 6 plus 3 6 is indeed 5 6. Let's move on. Number 3, we have 3 eighths plus 3 eighths plus 1 eighth. And we need to mark that on a number line and eventually evaluate that expression. We'll start that off by marking off our 0 and our 1 whole mark. So 1 whole in terms of eighths would be 8 eighths. And now we need to divide this up, partition it into eighths. That would be the halfway point approximately. And you can think to yourself, half of 8 would be 4, so that would be our 4 eighths mark. So again, that would be equivalent to 1/2. If you're thinking that, good for you. Now we want to start and continue actually dividing up our number line. Okay, so now we've got 4 equal parts. We want to have 8, so let's divide that once again. If I'm moving a little too fast for you, feel free to pause the video and continue whenever you're ready. All right, let's continue. So now we've got our starting point would be 1/8, 2/8, 3/8. So right in here is our first add end. You can see that, 3/8. And we're going to add some more to that. Let's see what happens. So we started off again at our 0 point. We went 1/8, 2/8, 3/8. That's what we started with over here, 3/8. Now we want to add 3 more to it. So let's go ahead and do that. 1/8, 2/8, 3/8. So that's 3 more eighths. And then finally we want to add 1 more eighth to that. There we have that. So again, this section would be 3/8 and another section of 3/8 plus a section of 1/8. Let's see what we come up with. So again, 3/8 plus 3 more eighths, so that brings us to 3/8, 4/8, 5/8, 6/8. Okay, that would be the 6/8 mark. And then when we needed to add 1 more eighth to that, 6/8 plus 1 more eighth, that would give us 7/8. So right there would be our sum. With our add-ins of 3/8, 3/8, and 1/8. So you can see that our sum would now be 7/8. And again, we're proving that if the denominator is the same, you just simply add up the numerators. 3 plus 3 is 6. 6 plus 1 is 7. And there we have our answer. So let's move on to the next one. Now we've got this one is a little bit different. When you look at these, we've got 2 times 1/4 plus 1/4. So let's go ahead and partition our number line up by fourths. So this would be 0/4. And then we'll take a look at 1 whole. And 1 whole in terms of fourths would be 4/4. So then the halfway point would be, well, half of 4 would be 2. So there we go again. We have 2/4. You're thinking that, good for you. And we want to partition this up again. So I know that this would be 1/4, and then over here, well, this would be 2/4. 3/4 would be right in here, approximately, and 4/4 would be 1 whole. So now let's see what this means over here. We've got 2 times 1/4. And remember, order of operations, we want to multiply before we add, because multiplication and division are on a higher level of the order of operations process than addition would be. So in this case, we do have just multiplication here and addition. So we'll do our multiplication step first. So 2 times 1/4. And that's kind of easy to see. Let's check it out. 2 times 1/4. So really don't know exactly what that would be until we kind of figure it out. Here, maybe you can figure it out mentally. Good for you. So we've got 1/4. And then we want to do that again, so 2 of those, so 2/4. So you can see that 2 times 1/4. This distance would be 1/4. And if we doubled that, like the 2 was telling us, and we would end up with 2/4. Then we have to add an additional fourth to that. Look at that. So let's see where that leads us. We've got 0/4, 1/4, 2/4, 3/4. That's where we would end up. So there it is, 3/4. So 2 times 1/4 plus 1/4 would equal 3/4. Moving on to page 2, number 5. For numbers 5 through 8, express each fraction as a sum of 2 or 3 like fractions and show on a number line. Okay, we can do this. So now I'm going to take a look at this. Really, so we're starting off with our sum, and we have to figure out what the addends are. So again, this would be our starting point, or 0, and our denominator's 9, so we'll have 0/9. And we want to work all the way to 1 whole, or in terms of ninths, 1 whole would equal 9/9. So let's try to partition this up a bit. Ninths might be a little bit more difficult for you. I'm going to try to do this. On a number line or math drawings, you really don't necessarily have to be perfect. Ideally, they'd have to be equidistant. Should be equal parts here. All right, so then let's see how this will work out. We'll try to mark this off in ninths. Okay. And when you're dealing with an odd number, it's a little bit more difficult to figure out where your center point would be. It would be like around 4.5 ninths. So 4/9 and 5/9 would be right there. Anyhow, let's try to break this up a little bit. So we want to get to 7/9. So we've got 1/9, 2, 3/9, 4/9, 5/9, 6/9, 7/9. So we can see that 7/9 would be right in here. You could see also, you could continue 8/9 and then 9/9 would be there, so kind of double check our work there. So yeah, we want to get to 7/9. So really there are several ways you can do this. So let's start off with 0/9, and we'll come up with our first fraction here. We can figure it out. 1/9, 2/9, 3/9, 4/9. So this would be the 4/9 point on the number line. So let's take that, 4/9. Our direction said we had to have 2 or 3 add-ins, so why don't we go with 3? So 4/9 plus this distance would equal 1/9. Probably thinking that. Good for you again. So that's 1/9. So it's one more up here. So we'll just do 1/9. Okay. And then we need to eventually get to 7/9. So this will be our third add-in, this distance here. So you can see that we want to go ahead and add that in there. So it's a distance of 1/9, 2/9. And there you have it. We started with our sum and we broke it down into 3 add-ins. And notice they all have the same denominator. So if you check your work, 4 plus 1 is 5, 5, 6, 7, 9, so we'd be right back to our original fraction. And if you're looking at these distances, you can see that this distance represents the 4/9. This is the 1/9, and this distance is 2/9. Let's move on. The next one we have 4/6. So we'll label our number line. Probably get the hang of this. Good for you. There's our one whole point, and in terms of 6, we'd have 6, 6. Center point would be 3, 6. 6 divided by 2 will bring us to the halfway point, or 3, 6. And we want to mark off these, so there should be 3, 1, 2, 3, 4, 6, 5, 6, 6, 6. Okay, so now we want to break this down. We can do this. So why don't we do our partitions first, and then we'll figure it out from there. Okay, there's one. There's another. Again, you could mix it up. You could have 1/6 at first plus 3, 6. And it's really up to you. As long as you, let me just back that up a second. As long as you get to your target fraction here, and that would be 4/6. Let's write that in there. Okay, so we want to get to 4/6, and we just did that. And this time we have 2 add-ins. So 4/6 equals, okay, what's this distance here? 1/2/6. You can see that up there. That distance would be 2/6 plus another distance of 2/6. You're probably thinking that, good for you. And then if we check it out, our denominator is the same. So we can just add the numerators. 2 plus 2 equals 4. There you are. Let's go on to number 7. 10/8. Oh, we have something a little different going on here. As we've seen in our fourth part of our fractions module, we dealt with fractions greater than 1 whole. And anytime your numerator is larger than your denominator, you're going to have a fraction greater than 1 whole. So that's what we have. And our denominator is in eighths. So I'm going to do this a little differently. So we'll start off with our 0.0 0/8. And now we want to get to 1 whole a little bit sooner. So I'm kind of like estimating in my head here, thinking, okay, 10 is a little bit larger than 8, so but it's not quite twice 8, so we're not going to be dealing with 2 wholes. It'll be a fraction greater than 1 whole. So let's continue here. I know that would be 8/8. Let's extend it out a little bit. Let me just figure out how far our distance would be. Well, that would be 4/8. It's about halfway between 0/8 and 8/8. 4/8 would be right in the center. Okay, and then that would be 1/8. Back that up a little bit. Okay, so then we want to back that up a little bit. That would be 2/8. Then we'll split that up a little bit more. So 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. We'll kind of continue this distance. That would be 9/8. So again, it's greater than 1 whole. Continue it once again. 10/8. Oh, and there's our fraction, our target fraction right there. You can see we wanted to come up with a sum of 10/8, and we've done that. Now we have to figure out what our add-ends would be. So now we could do this a variety of ways. You could start, I'm just randomly picking, there's 3/8, 1, 2, 3/8, plus another number of eighths, and again we want to get to 10/8, so we'll add a few more, and there we have it. So now we have to figure out what our add-ends would be. So 10/8 equals 1, 2, 3/8. plus 1, 2, 3, 4/8 plus 1, 2, 3/8 again. If we check, since our denominators are the same, we can add up those numerators. 3 plus 4 is 7. 7, 8, 9, 10, we'd be back to 10/8, and there you go. And you can mix these up. You could start with 2/8 plus 6/8 plus 2 more 8s. That would get you to 10/8 too. There are several ways to do this. Let's move on to our last problem. We have 8/4. You can see that our denominator is 4, so we'd be dealing with fourths. And it's twice that, so we'd be dealing with a fraction greater than 1 whole, and it's actually twice as great as the denominator, so it's going to equal 2. So not only will we be dealing with a fraction greater than 1 whole, we'll be dealing with a fraction equivalent to 2. So there would be 0/4. This would be 4/4. 4/4 is equivalent to 1, and then 8/4 would be equivalent to 2. Let's mark this off on the number line. So that would be 2/4. That would be 1/4, 2/4, 3/4. And we'll continue. I like to get this equidistant between there. It helps me to divide it up visually. 5/4, 6/4, 7/4, and back to 8/4. So we can pick a number of these. So we want to have, we could try 2 add-ins for this one. So we'll make 2 jumps here on our on our number line. So you can see the first add-in. You can count that up, and you're probably thinking, okay, I can do this. 1, 2, 3, 4/4. Aha! So 8/4 equals 4/4 plus another jump of 1, 2, 3, 4, 4/4. Would get you back to 8/4. So once again, we proved that if your denominators are the same, you can just add up those numerators. So 4 plus 4 equals 8. And in other words, you could say 8/4 equals 2. 4 over 4 would be 1, or 4/4 equals 1. 4/4 equals 1. So it's as easy as 1 plus 1 equals 2. So that was a quick look at adding fractions with like denominators on a number line. Thanks for checking out Worksheets and Walkthroughs.com. We'll see you again next time.